Page 685, lesson 11.4. This is the second half of the lesson on adding and subtracting rational expressions. So previously we looked at what to do if the denominators are the same. Today we're going to be looking at what to do if the denominators are different. So just like when you added and subtracted fractions, you have to have a common denominator. So if you look at problem 3, for the first time in this section, we have fractions that have different denominators. So we have to get a common denominator, preferably a least common denominator if we can. And so what we're going to look at on this one is both of these denominators are monomials. There's nothing being added or subtracted. So basically, if you want to just look at the numbers first, look at the 6 and the 2, if you can ignore the variables for a minute. If you could imagine if your denominators were 2 and 6, you would know 6 would be your least common denominator. We also need to get the variable parts the same as well. To get the variable parts the same, we need to have the highest exponent that we see of the variable for a monomial. So we have an x and we have an x squared, and so we would need an x squared for those to be the same. So 6x squared is going to be our least common denominator. And so what that means is we have to think about what we need to multiply these by. So the first fraction, if we multiply the denominator by x, also we need to multiply the numerator by x then to get an equivalent fraction. So that would be 5x over 6x squared. And then on the second fraction, 2x squared, we need to multiply that by 3 to get 6x squared. And so that gives us 9 over 6x squared. At that point, denominators are the same. We can just add the numerators together, which would give us 5x plus 9 all over 6x squared. And once again, if you want to put parentheses around the numerator, so we make sure we don't cancel unless we see another 5x plus 9 somewhere, then you can do that. So if you look at the got it number 3, we've got a similar situation. We have monomials in the denominator again. So first we can look with our numbers, then we can look with our variables to try and get a common denominator. So with the 7 and the 3, we would need a 21, and then we'll look at the variable parts. So we would need y to the 4th with the variable parts. We need the highest power that we see. And so I'm just going to rewrite this just to give myself a little bit more space. So 21y to the 4th is going to be our common denominator. So the first one, we've already got the y to the 4th, so 7 times 3 is 21. So that would be 9 over 21y to the 4th. The second fraction, we've got a 3, so we need 3 times 7 to give us 21. We've got y squared, so y squared times y squared would be y to the 4th. So then that would be 14y squared over 21y to the 4th. And then at this point, we're just going to add the numerators together. Usually when we add these together, they're going to write this answer in standard form. So we're just going to do a little switcheroo here. And we'll put 14y squared plus 9 all over 21y to the 4th. And that would be our answer for that problem. So problem 3 we just did, we were adding expressions that had the same denominator. Now we're going to be subtracting expressions that have, it was adding expressions that had different denominators. Now we're going to be subtracting expressions with different denominators. So if you look at this one, denominators are different. And again, these are binomials this time. So if you want to put up your force fields here, and then basically we're going to need both of those binomials. We need d minus 1 and we need d minus 2. So that's where they multiplied both of those. One thing you need to watch for is at some point they are subtracting here. What I would probably do is I would probably just add the opposite there. A little different than yesterday. Yesterday we had just a bunch of terms being added or subtracted together. This time these are factors up here in the numerator. So since they're factors, we just add the opposite to that first factor, and then we're just going to distribute from there. We don't have to do opposites to everything because it's going to get distributed in anyway. So I would have this a little different than the book then. After I distribute, I would have it like this. The book waited till later to distribute the negative, and that's fine. But basically I would be skipping a step then, kind of, and then that would be our answer. And again, you can put parentheses in the numerator if you want. So let's look at the got it 4. So on this problem, a little bit different than the last problem is that they only have a monomial in the second fraction. They only have one term in the second fraction. And so if you want to just go ahead and add the opposite there, you can. Put up your force fields here if you want. So for our denominator, we would need both of these binomials. So the first fraction, we would need to multiply that by c minus 2. And the second one, we would need to multiply by 3c minus 1. And at that point, the denominators are both going to be the same. So if you want to shortcut it, I'm okay with that. In other words, rather than rewriting them as two separate fractions and then saying, okay, now we're going to combine them together, if you want to just say the denominators are the same now, I'm just making this one fraction. I'm okay with that. So this first part we could distribute. So this would be c squared minus 2c. And then the second fraction, if we distribute that, would be negative 12c plus 4. And like I said, we know the denominators were going to be the same. That's why we went ahead and are allowed to just go ahead and combine that into one fraction at that point if you want. And then at this point, we are just going to see if we can do any simplifying in the numerator. So these middle two terms here are like terms that we can combine. So that'd be c squared minus 14c plus 4. And at this point, you can put parentheses around the numerator if you want. Since we have a trinomial in the numerator, there is an outside chance that that could be factored. I'm not going to write the denominator here, but notice there's no way we could get this 3c minus 1. We just have a c squared. We don't have a number in front of it, so I can't get a 3c in one of the binomials, but potentially I could get a c minus 2. So if we do c minus 2, we'll try that. The other one, since we have a plus 4, that would also have to be minus 2, and that would also be c minus 2. That only gives us minus 4c, not minus 14c, so that doesn't work. So the answer that we had previously is as far as we can go with this problem. Actually, backing up to problem 4 for a minute, there was something I overlooked at the time when we were doing this problem. If you have a subtraction problem like this, rather than going through with common denominators and everything first, it might be easier if you just go ahead and add the opposite first right away. and then you can worry about a common denominator. So in other words, if we change that to plus a negative 2, and then now we can get our common denominator, and then we don't have to worry about, like, do I do the opposites to everything or do I not do the opposites to everything? And then that's the same as just d plus 8, which is what we got earlier. So this actually would be my recommendation, just a little different than the book. Just go ahead and right away add the opposite, and then you don't have to mess with it anymore. So to start off for this problem, if you want to go ahead and add the opposites like we did earlier in the section, and we can put up our parentheses around the binomials and our denominators. So for this, the first fraction we would need to multiply by x minus 5, and then the second fraction we would need to multiply by x plus 2. And just to make sure everybody understands, that next step, I said our denominators are going to be the same. And you might look at that and say, well, they're not the same. One's x plus 2 times x minus 5, and one's x minus 5 times x plus 2. Well, commutative property, we can change the order of our multiplication, and so they are actually the same. So whichever one you want to put first doesn't really matter. Okay, and then we can distribute. So that'd be 4x minus 20. And then the second one we're going to have to FOIL out. So that'd be minus 3x squared minus 6x minus 2x minus 4. So then we can do a little cleanup work here in the numerator. This is our only squared term, so that would be negative 3x squared. And then we've got some x terms here. So that would end up altogether being a minus 4x and minus 24. At that point, just to verify that we can't simplify this anymore, we could try to get one of these to match with one of the factors in the denominator. To do that, first I would factor out a negative 1 in the numerator, just so it's easier for me to factor. And then I'm not going to bother writing the denominator because there's a good chance this isn't going to work. So we know it's got to be 3x and x. Everything's positive, so the signs both have to be positive. So my only chance is if I can use x plus 2. That's my only x plus factor in the denominator. So if we do x plus 2, that would mean we would have to have x 3x plus 12, because 12 times 2 is 24. And then if you check your middle terms, that's 6x and 12x, which is 18x. That's not 4x, so that doesn't work. So this would be our final answer for that problem. So if we look at the lesson check, number 3 is one where we have different denominators, and these are back to monomials like we had earlier. And again, I know I'm going to need to get common denominators, so I'm just going to rewrite this so I've got a little bit more room. So for this, with the number parts, with the 8 and the 6, if 6 and 8 were our denominators, ignore the variables for a minute. 24 would be a common denominator. And then with b squared and b cubed, we need the higher exponents because we have to multiply it by something to get that. So the highest exponent in these monomials is b cubed. So 24b cubed would be our common denominator. And now we need to think about what we would need to multiply these denominators by in order to get that. So for the first fraction, to get that, we would have to multiply by 4b. Again, at this point, we know the denominators are going to be the same, so if you want to go ahead and put that as one fraction here, we can. So that'll be 16b. Then the second fraction, we just need to multiply by 3. We've already got the b cubed, and so that would be 15. And again, if you'd rather just have it as two separate fractions first, if that's too much that we're doing at once of getting a common denominator and combining them to one fraction, definitely feel free to keep them as two fractions first. At this point in the numerator, we could see if we could factor anything out. GCF's our only option because we don't have a squared term, and GCF is 1, so there's nothing we can factor other than a 1. That's not going to help us, so that would be our answer for this problem. So this gives you an idea of how to add and subtract rational expressions.